All right, so what we're going to do here in lesson 20 is we're going to introduce logarithms. Now, you may have heard of logarithms and maybe they don't have a very good reputation. But trust me when I say logarithms are great and they can be very easy if you understand them and you practice them, okay? Logarithms are basically exponential statements. We know this is an exponential statement. You've seen this already. We know that 5 to the third power is equal to 125 because 5 to the third power is 5 times 5 times 5. Well, exponential statements, they can actually be rewritten as logarithms. There is an equivalent statement that's a logarithm that basically says the same thing as this. And here's what it's going to look like, okay? All right, so the same thing, this is the exact same thing. We would write this as log base 5 of 125 is equal to 3, okay? So what's the big difference here? So both of them have a base. This is the base of the exponent. This is the exponent. This is the base. Over here, this is the base of the exponent, 5, and this is the exponent, 3. I sometimes call this the product, and over here the product is inside parentheses. And here's the big difference. In an exponential statement, the other side of the equal sign is the product. But in a logarithm, the other side of the equal sign is the exponent. And so what we're typically saying in a logarithm is this: what is the exponent? That's what a logarithm is asking. When we're trying to find out what is the exponent, then we want to use logarithms. Okay, so here, what this is saying here is what exponent on 5 will give us 125? 5 to what power will give us 125? Well, we know that 5 to the third power is 125, so the exponent on 5 that gives us 125 is 3. Okay, so log says what is the exponent, and in this case the exponent is 3. Okay, so I could write another logarithm expression. Let's say that I said log base 2 of 32. And so what this is saying is what exponent, 2 raised to what power, will give us 32? So it's basically saying 2 to the power of what is equal to 32. Okay, sorry, this isn't equals. It's saying 2 to what power is equal to 32. Well, we know that 2 to the fifth power is equal to 32. And therefore, the answer to this logarithm is 5. Okay, so that's basically what logarithms do. Let's look at how to convert between an exponent and a logarithm. All right, so here's some steps on how to convert an exponential equation into a log equation, okay? And we're going to do some examples right here, okay? So the first thing you're going to do is you're going to write the word log, okay? So let's do this one right here, okay? We'll draw a little arrow here. Step 1, write the word log. So I'm going to write the word log. There we go, log. Then it says write the base of the exponent, the base of the exponent. Okay, well here's the exponent and here's the base, 1.23. So it says write that, the base of the exponent, little, and next to the bottom right of the g in log. Okay, so here's the g in log. The bottom right is right here. Okay, so right down here we're going to write the base, which is 1.23. So we're going to say 1.23. Okay, so see what it says? Write the base of the exponent, little, and next to the bottom right and of the g, and that's where I wrote it. Okay, then it says write whatever is on the other side of the equal sign. Okay, and here's the equal sign, and on the other side of the equal sign is a W. Okay, it says, well, write that thing in parentheses after the word log. Okay, well, here's the word log. So in parentheses after the word log, I'm going to put a W. Okay, there we go. And then it says write an equal sign. So I'll put an equal sign here. Got to squeeze it in there. And then it says write the whole exponent on the other side of the equal sign. Well, here's the other side of the equal sign. And what is the exponent? The exponent is 8. So I'm going to write an 8. And sure enough, here's our logarithmic equation. Okay? And so log base 1.23 of w of 8, or equals 8, is the same thing as 1.23 to the 8th power is equal to w. Okay? So now let's convert. Let's do this one and this one and this one. We'll see how it goes. So here, we're going to write the word log. Log. We're going to write the base of the exponent, which is 2. Put a 2 here. The other side of the equal sign is 4.7. So in parentheses, we'll put 4.7. Put an equal sign, and then the exponent is x. So we'll just put an x here. And so sure enough, there's our logarithmic equation. Okay. Why don't you try these two before I do them? You can pause the video. So the first thing we're going to do is we're going to write the word log. Then we're going to write the base of the exponent, which is e. Remember that e is a number. Okay. Remember that e is a mathematical constant approximately equal to 2.718. Okay. So let's go ahead and write e. So log base e. Then on the other side of the equal sign is 9. So we'll put in parentheses 9. Then we'll write an equal sign. Then we're going to write the whole exponent, which is x minus 5. X minus 5. There we go, and we did it. Now, before we move on to this last one, I want to tell you that we actually have a special logarithm for log base e. We do not really ever write log base e. Okay? What we write instead is the letters ln. Okay, ln means natural log. So ln means natural log. Okay, natural logarithm. Okay, or natural log. Okay, so instead of writing log base e, we write ln. Okay, because ln means the same thing as log base e. Okay, and so what we're going to do is we're going to change this log base e here. Okay, we're going to write something else. We're going to write natural log. And so the way we would convert this is actually we would write ln. There's no e there. The ln implies that the base is e. Okay, and so this is the logarithm we would write when we convert this, ln. Okay. Now let's do this one. 10 to the negative 7 power is equal to this very small decimal. So first we're going to write the word log. Then we're going to write the base of the exponent, 10. We're going to write it right here. Then in parentheses, we're going to write what's on the other side. 0.00000001. Okay. Then an equal sign. And then the exponent, negative 7. Negative 7. Okay. And so this is the logarithm of this. But I do want to tell you that frequently we do not write log base 10. Log base 10 is what is called the common logarithm. The common logarithm. And the common logarithm is very useful and important. Okay? And I'm going to show you what we write instead of log base 10. Let me get rid of this. There we go. And here, what we do is this. When we have log base 10, we just write the word log. So if we just write the word log, that means log base 10. So you can skip writing the 10 and just write the word, and then just write the word log. Okay? And so that's what we're going to do here. We're going to modify this here. We're going to get rid of the 10, and we're just going to write the word log. L-O-G. There we go. With nothing written down here, okay? Just the word log, that means log base 10. And so this is log base 10, and it is the logarithm form of this, okay? All right, now what we're going to do is, the last thing we're going to do is we're going to go the other way. We're going to convert from logarithms, we're going to convert them into exponential equations. All right, so now we are going to convert log equations into exponential equations. We're going to go the other direction. Okay, so we're going to start with a logarithm and we're going to turn it into an exponential. So here's my example here. You may want to write this in your notes. And when we see a logarithm, basically what we can do is we take this, we start here. We start with the base of the logarithm. So this is base 2. And what we do is we take the base and then we say to the power of whatever is on the other side of the equal sign. So it's 2 to the power of 5 equals what's inside, 32. So this would become 2 to the power of 5 is equal to 32. And that's how we convert from a logarithm into an exponential equation. Okay? So let's go ahead and convert this one here. We're going to do 3 to the power of 4 equals 81. All right, so this would be 3 to the power of 4 equals 81, which is a true statement. Okay, let's do this one now. We're going to do 1.2 to the power of w, okay, and then equals 35. So 1.2 to the power of w is equal to 35. Okay, 1.2 to the power of w equals 35. Okay. All right, let's do this one now. So we're going to do, we need the base of the logarithm. Well, it's not showing a base, but we know that the base of the natural log is e, and so it's going to be e to the 7th power equals y. E to the 7th power, okay, so e to the 7th power, e to the 7th power equals e to the 7th power equals y, okay, equals y. And so now this is our exponential statement. And we can transform this back into a logarithm just to make sure. We're going to do log, okay, log base e, which is natural log, of whatever is on the other side in parentheses, yep, of y, equals whatever the exponent is, 7. And there it is, okay. All right, let's do this last one here and we'll wrap it up. We're going to take the base. This says log. There's no base showing. And if the base is not showing and it's the word log, then we know that it's log base 10. Okay, so it's going to be 10 to the 3rd power. 10 to the 3rd power. Okay. So 10 to the 3rd power equals 1,000. Equals 1,000. Okay. And there we did it. We have converted 3 logarithmic equations into exponential equations.